Hello everybody, welcome to this session on statistics, and here we will be discussing a few problems on mean, median, mode and standard deviation as well. So let's start. If the median of 5 different positive integers is 20, find the least possible sum. Now median is the middle term, so when you have 5 numbers, the middle term will be the third number. So to get the least possible sum, the numbers have to be 1, 2 before 20 and then 21, 22 after 20. So the sum will be 66. Let's go to the next question. Range of a set is 17.3. 3 is added to all the elements of S and all the elements of S are divided by 10. Find the new range of the set. Now if 3 is added to each element of the set, the range remains the same because the range is the difference between the highest value and the lowest value. If each number in the set is divided by 10, the range is also divided by 10. And the old range is 17.3, so the new range will be 17.3 by 10, which is 1.73. The next question. Given 5 positive integers, if the median is 6, mode is 2 and mean is 5, find the numbers. Median is 6 and we have 5 numbers, the third number will be the median, so let the numbers be say 2, 2, 6, x and y. I've just taken 2 as twice because 2 is the mode, the most frequently occurring number, and the mean is 5. So mean will be 2 plus 2 plus 6 plus x plus y divided by 5 is 5. So x plus y is 15. So since the numbers are positive, the possible choices for x and y are x is 6, y is 9, or x is 7, y is 8. Since the mode is 2, x cannot be 6 because then you will have 6 also as the mode. It becomes bimodal. So the numbers are 7 and 8. So your set will be 2, 2, 6, 7, 8. Moving on. Given a set of values 14, 12, 16, 11, 22, 21, 10, 17, 11, 12, how many values are greater than the median but lesser than the mean? Now to find the median, arrange in either ascending or descending order. So if we arrange these in ascending order, we get 10, 11, 11, 12, 12, 14, 16, 17, 21, 22. There are 10 numbers and when there are 10, the median will be the middle of the 5th and 6th value. That is 12 plus 14 by 2 will be 13. And the mean, if you add the values, mean will be 146 by 10, which is 14.6. So we need to find how many values are greater than the median but lesser than the mean. So we have only 14, which is greater than the median but lesser than the mean. So only one value is greater than the median and lesser than the mean. So the answer is just 1 here. Okay, the next question. A person scored an average of 32 points per game over the first X games. In his last game, he scored 14 points and his average became 30 points for the first X plus 1 games. How many games were played initially? So your total score, initially there are X games, so total score will be 32, average is 32, so 32 will be that sum divided by x. So a total score is 32x. Now we are adding one more game. So you get, and for that game he scored 14 points. So you'll get 32x plus 14, and since you're adding one more game, total number of games is x plus 1. So we have 32x plus 14 by x plus 1 and the new average is 30 points for the first x plus 1 game. So this becomes 30. So solving we get x equal to 8 and 8 games were played initially. The last question for today. The dot plot shows the distribution of scores for 2 classes of 24 students each. Which class has a smaller standard deviation? Now standard deviation measures how far the data points are clustered around the mean. A small standard deviation means the data points are closely clustered around the mean. And large standard deviation means the data points are spread out. So if you look here, this is a larger standard deviation and this is a smaller standard deviation because the data points are clustered around the mean. So we can say that class A has a smaller standard deviation. So that comes an end we come to an end for the problems for today. We have mainly discussed a few problems involving mean, median, mode, range, and standard deviation. Thank you.